Hi everyone, welcome back to the channel. In this video we're going to design some precast concrete circular slabs with openings. I'm going to show you how to model and design precast circular slabs. We're going to split the slab into two and we're going to have two openings, one on each side. Okay. The loads we're going to look at is the self weight, which is of a 450 slab, 600mm fill, and vehicular loading from LM1 and LM2. For the purpose of the video and the model, we'll use this CAD file here. So we're going to use this as a guide to help us model the slab in Robot. It's handy to prepare a second file just showing the geometry, because we can import that directly then into Robot. So we'll open up Robot. We'll go New Project. We'll use Shell. Because geometry is simple, just circle, split into two, couple of openings. The easiest way to do it is just to import it. So you just find your CAD file, you open the CAD file. Just want to change some of the properties here. So we'll just keep the default values. We'll open it up. Now we want to choose the insertion point here. So let's put in the origin 0, 0, 0. Okay, just hit apply. So the units for the CAD file would have been in millimeters, and we're dealing with meters here, so we just need to apply a scale coefficient. Okay, that's what I'm doing here. Just check the top. And once you click on the section, you can do some checks to make sure. So all our elements come in as bar elements. So we can use this now to create the shell elements. So we'll select all and we'll just create thickness now. So we'll go New. Sorry, so it's thickness, then it's New. And here we're going to homogeneous thickness. We'll say it's 450 mil. I'll put in 0.45 or 450, sorry, because it's in millimeters. Check C4050. Add. So we're going to select panels. So we can use creation with internal point. Okay, so just click an internal point and it creates the panel automatically. Just double check. You can double check on the left hand side that the thickness has been applied correctly. Do the same on the right hand side. Now we've our two slabs. So our two shell elements. Now we'll just check the openings. So same option. Click on the internal point and it's recognized them as an opening. Yeah, so at this stage we're going to have a look at these arrows. So they're the local axes. We just want to make sure that both are the same. Okay, so we'll just turn on the local system. So we have a lot of arrows here. So we have shell, we have the beams. Yeah, we don't need these beams anymore. We only use them to build the shells. We can get rid of all them. Still have some nodes there that are not relevant. Again, brought in from CAD. So if we click on all, now we can get rid of all the nodes. Just want to keep the local axis and the global axis the same here, guys. That's what I'm doing. It's just easier when you're looking at results. Okay, so local system orientation, 100, and we're just going to apply to all panels. And here we go. Local axis, global axis, all the same. So I just want to insert some steel lids here. You can see we have 2 openings, but we're going to have some steel lids like D400 lids or whatever they're going to be. So I'll just create them now. Just going to go 50mm steel. Change my concrete back to steel S275. Just say add. Again, same approach. Panel. Click and click. Okay. So here we go. We have our precast and we have our steel lids. Again, just do the local axis, matching the global axis. And that's all done now. If I right click and go to display, I can just select this option here and it allows me to see the different colors, different elements. It's just a nicer view in my opinion, but you can do this whatever way you want, guys, but it's a nice way to look at. Okay, so at this stage now, we have to correct geometry, we have to correct thickness. Okay, so the next step is going to be applying the support conditions. So we can select supports. We're going to go nodal, linear, or planar. We're going to go linear here for our case. We want this slab is supported all the way around its edges, so we'll go linear. Go new. Let's call it lid support. And we're going to say it's fixed in the X, Y, and Z. So it's a pin support. So we can click manually here, individually if we want to, or we can select all the edges. So if we hover our mouse over the element, we can see that we have, it's showing us all the different edges, so we can just pick the edges we want. Now it obviously picks the internal edges which we don't want, so we can just click delete and click on tick 2, and that's the quickest way to do it. All right, so we can just look underneath and look on top, and we can see that we have all the edges. Now we don't want a continuous connection between the steel lids and the precast. So again, we'll just do a linear release here. So we'll go new. We'll just call it steel lid release. So here we pick the directions. So we just want steel lid to create load down onto the precast. All right. So we'll just go element 48, 49 and hit apply. Yeah. So what we've done here is just a linear release. So it's only taking the load vertically down. So we don't have any connection to precast lids. There's no half joint. It's just a butt joint. So the easiest way we can do is if we select everything on the right hand side. Okay, I'm just going to move it. So edit, move, just move it 10mm maybe, zoom in. So here we go. Now we have a gap and it shows that there are 2 different elements. It's just the easiest and quickest way to model these in Robot. So that's the geometry. We have chosen the materials, we've chosen the thicknesses, supports, linear release on the lids. So the next step will be to apply the loads. So next week we'll apply the loads, we'll run the analysis, and we'll show you how to design the lid from there. Okay, thanks very much for watching, guys.